Welcome to Unit 5. At this point, you have already been through the exercise in 5.1 where we explore triangle congruency relationships and should already recognize the theorems on this page. But just to review very quickly, we have 5 ways to prove two triangles congruent. The first is the easiest. It's side, side, side. And what that says is that if I have two triangles and they have 3 pairs of congruent sides, then the triangles themselves are congruent. Then we have side angle side, which says if we have two triangles and they have 2 sides that are congruent, an angle that is congruent, another pair of sides that are congruent, then the triangles themselves are congruent. Now, if you notice, the angle here, this angle, touches both of the pairs of congruent sides. Now, that's important because if we were to put the angle instead over here, we would no longer have a congruent triangle. It would be ASS, and because that spells a bad word, it is not a congruency relationship. Well, there are other reasons why, but that's a good way to remember it. Next, we have angle side angle. And what angle side angle says is that if you have 2 angles and the side in between them congruent on 2 triangles, then the 2 triangles themselves are congruent. So here you can see angle L is congruent to L prime, M is congruent to M prime, and the side length, LM, touches both angles, therefore it's ASA because the side is in between both the angles. Then we have AAS. Now if you look, these are really similar, right? They both involve 2 angles and a side. What do you see as the difference? What I can see is that here the side in AAS only touches one of my marked angles, whereas the side over here touches both of my marked angles. Therefore, the one on the left is ASA because the side is squished between the 2 angles, and the one on the right is AAS because the side only touches one angle. Then we have hypotenuse leg, and this one only works for right triangles. So if we know that the hypotenuse of a triangle and one of the legs of a right triangle are congruent, then we know that the 2 triangles are congruent to each other. All right. Now, why did we learn all these laws? It wasn't just to boggle your mind. It was to allow us to prove 2 triangles to be congruent. So here, I have 2 triangles, ABC and EDC, and I want to prove that they are congruent. And looking at this proof, they already give me that segment AB is congruent to segment ED. It's marked. And they give me that angle B is congruent to angle D, also marked. And I want to prove that the 2 triangles are congruent. So, looking at this picture, I only have 2 pieces of information right now. I need a 3rd piece of information. Now, if you look, this angle here and this angle here, those are congruent because they're vertical angles. I'm going to use that information in my proof. So, let's start the proof. We write down our givens. AB is congruent to ED, and angle B is congruent to angle D because they're given. Okay. Now, let's talk about those vertical angles. I know I need them. That would be angle BCA is congruent to angle DCE by the vertical angles theorem. Now notice, I was being really careful to write my letters in a very specific order here. I wrote BCA, so BCA, that went 1 loop, 2 loops, no loops, if I'm looking at the angles, So when I write DCE, I want to write the letters in the same order. 1 loop, 2 loops, no loops. DCE. That's how I chose the order of my lettering. All right. Now let's take a look at what we have. We were given a side, and we were given an angle, and then we just proved an angle to be congruent. Now here's my question. I have two A's and an S. Is it ASA or is it AAS? Well, looking at the side in my diagram, the side only touches one of the congruent angles, so it must be that the triangles are congruent. So triangle ABC is congruent to triangle EDC by AAS, because the side only touches one of the angles in the diagram. And we've done what we were asked to do. We've proved the triangle congruent. So I'm going to do my colored in box, and I'm done. Okay, I'm going to skip this proof for the time being and come back to it in half a second. But let's look at this one now. This proof, we have to do a little bit more work, but not too much more. But let's look and see what they give me. L is the midpoint of JN. So if L is the midpoint, that means that it divides that segment directly in half, which is going to make JL congruent to LN. I'm going to use it in my proof. They then tell me that angle KJL, so KJL, this angle, is congruent to angle MLN, lovely. And they tell me that line KL is parallel to line MN. Now remember, parallel is different to congruent, so don't jump to that conclusion. But let's write down our givens. L is the midpoint of JN, and angle KJL is congruent to angle MLN, and KL is parallel to MN. All of those are given. And we already realized that we could go ahead and write that segment JL is congruent to segment LN because that's what a midpoint does. That's the definition of midpoint. Okay, now let's look and see what we have so far. What I've proven. I have proven an A here, and I have proven an S here. I only have two pieces proved. I need a third piece. So let's look back up at the diagram. We have a pair of parallel lines, and I can probably use some of our parallel line theorems to help me out. Looking at this, if I were to extend KL, extend MN, and extend this down here, and just focus on the blue lines, I can see that those would be congruent, those angles there. So I'm going to use it in my diagram. That's angle JLK. Angle JLK is congruent to angle LNM. And they're congruent because they're corresponding angles, if you remember that from before break. So they're congruent by the corresponding angles postulate. Now, that gives me an A. That's an angle. So let's look. I've got two A's and an S. So is it ASA or is it AAS? Well, looking at this, my segment is smushed between the two angles. Let me put two loops on that blue angle. There we go. So that means that it must be, that the triangles must be congruent. Triangle KJL is congruent to triangle MLN by ASA. And we have now proven the triangles to be congruent. Done. Okay. Next thing we need to worry about are overlapping triangles. And overlapping triangles are phenomenal if you know how to deal with them. And the key to these is to redraw them, separate them, relabel them, and then do the proof. So, looking at this, I am trying to prove FGI is congruent to HGI. So this is where I would probably use a highlighter or something with color to help me see the different triangles and their overlap. So FGI goes from FGI, lovely, and then HGI, HGI. Now what I'm seeing is that there is an overlap on GI. That's going to be really important. So I'm going to redraw my triangles with a pen this time. So this is F, I, and G. And then over here, we would have G, I, and H. Now, they give me that GF is congruent to GH, so I can even mark that up here. And they tell me that GI bisects angle FGH. So FGH is the angle up here, so if it's bisecting the angle, that means that those two angles are congruent. So those angles down here are congruent. Now, the overlap. The overlap's important because they both share that length in common. GI has to be congruent to GI because it's the same angle. So the overlap is very important. So looking at my new diagrams down here, I have SAS. So these would be congruent by SAS. Boom. I want you now to go through and label the other two diagrams on here, separate them, and label them and figure out what law you would use. Okay? Let's go back now and do this proof real quick. Okay, it says that GI is the perpendicular bisector of FH. So GI is perpendicular bisector. That means that's a right angle, and that means perpendicular part. And bisector mean those are congruent. That's fine. Now, it's an overlapping triangle, so I'm going to want to redraw it. I'm going to grab my highlighter, and I'm going to look. Oh, look, it's the exact same triangle we just had. Isn't that nice? Okay, but we're proving something different this time, and we're given different information. So, I have F, I, G. I'm given that that's there and that's there. And then we have I, H, G. And we're given this. Now, we know that GI has to be congruent to itself, so I can mark that as well. So let's go through and do the proof. I'm given GI is the perpendicular bisector of FH. That's my given. All right. And I therefore can say that FI is congruent to IH by the definition of bisector. Okay. What I can also say is that the measure of angle FIG is equal to 90 degrees by the definition of perpendicular, and the measure of angle HIG is equal to 90 degrees for the same reason. Therefore, they're equal to each other. Measure of angle FIG is equal to the measure of angle HIG by the transitive property. Cool. Now, if two things are equal, they are also congruent. I'm going to stop the video here, It will pick up in the next video. Please finish the proof. Do not stop.